Alright, so today we're going to be taking derivatives. The derivative of this function, x squared, is, so the first step is you get the exponent, which is this, and then you multiply this by the coefficient of the variable you're taking the derivative of. So x, right, the coefficient of x is 1, so 2 times 1, that's going to be 2, and then you subtract 1 from the exponent. So 2x to the 2 minus 1, which is the same thing as saying 2x to the first, which is just 2x, right? Basically, you just have to follow this. If you have some function that's x to the some power n, all you do is you get this n, and you multiply it times the coefficient, which is 1, so n x n minus 1. This is the derivative. Here's our function, and we take the derivative. All you do is get the n, multiply it times the coefficient 1, you get n. Then you just subtract 1 from the exponent. So if our exponent was n, then n minus 1. So I think probably do more examples. Let's say you have 3x squared, and we want to take the derivative of this. Well, all you do is you get 2, and you multiply it times the coefficient 3, so 6x, then 1 taken away from the exponent 2, so it's just going to leave us with 1. So our derivative is 6x. Let's try another one. Another way to write derivative is d of dx of some function. So again, x squared, we said it's 2 times the exponent times the coefficient, so 2 times 1 is 2, subtract 1 from the exponent, that's just 2x. Alright, so let's try taking the derivative of, let's do 4x cubed. So 3 times the 4, that'll give us 12, then we subtract 1 from the exponent, so it's just x squared, because 3 minus 1 will give us 2. So this gives us that. Alright, so let's try something different. Let's say we have a function and it's square root of x. Right? We normally don't get these, but another way to write square root of x, isn't this just x to the 1/2 power? Right, so now we have a function x to the 1/2 power, and we just follow the same rule we were following right here. We would get 1/2 times the exponent and times the coefficient, which is 1, so 1/2 times 1, that just gives us 1/2, then subtract 1 from the 1/2, and we get x to the minus 1/2 power. Okay, so this is the derivative. Alright, so you could actually write this neater, because this would just be 1/2. X to the negative 1/2 would just be 1 over x to the 1/2. And then we're multiplying. So this is just 1, 2, square root of x. So we took the derivative. Alright, so let's see. If we have, do another one. If we have 2x and we want to find its derivative, well, it's the same thing. It's 2x to the first power, so 1 times 2, this will give us 2, right? And then we subtract 1 from the exponent, so x to the 1 minus 1. And that's just 2x to the 0. Well, what's anything to the 0? Well, this gives us 1. So 2 times 1 is just 2. So basically, the derivative of anything linear is going to be a constant. So what I mean by linear is if you have, this, and you try to graph 2x, you would get this, right? Well, this line is linear because it doesn't have any curvature like this. It's not curving, it's a straight line. So if it has a straight line, then this just goes back to what we've learned in previous math, y is equal to mx plus b, right? This is the equation for a line. M, this right here is the slope, right? But isn't slope the same thing as change in y over change in x, right? Well, basically this right here is the same thing that we're doing when we're taking the derivative, except we're imagining that our change in y are infinitely small. So for an infinitely small change in y and an infinitely small change in x, what's the slope at that moment? So when we have something linear, when we look for the slope, well, the slope is a constant, because if we were to write the equation of a line for this function, we would get something like y is equal to 2x plus 0, right? So that means that 2 is the slope, right? But we just realized that when we took the derivative of this function, we got 2. Well, 2 is the derivative, but derivative means slope, so it's the same thing. See, 2 and 2. We can do another example. So let's say we have 3x plus 2, right? This is our function, and we want to take the derivative. Well, basically, when you're taking the derivative of this, it's actually something linear. You can actually take the derivative of this first, and then the derivative of this. So what I mean is, this would be the same thing as like d of dx of 3x plus d of dx of 2. Alright, what's the derivative of, let me fix this. The derivative of 3x, well, that was 3x to the first power, so 1 times 3, that's 3x, 1 minus 1. This is going to be x to the 0, so we can just say this is 1. 3 times 1 is 3. Now plus, and here's something new, the derivative of a constant. The derivative of any constant is going to be 0. That's because, remember how we were saying that derivative is the same thing as slope? Well, if we were to graph a function that looks like y is equal to 2, we would get something like this. Well, the slope, how much it's changing, you know, the rise over the run, well, it's 0, because our change in y over change in x. Sure, we could be changing in x, but change in y, it's not growing any taller, so that means that the change in y is 0. So 0 over any amount of change of x will just lead to the conclusion that the derivative of any constant is 0. Alright, and there's another way to prove it is if we have, they're telling us take the derivative of 2, right? This is equal to the derivative of 2x to the 0. Because what's x to the 0? Well, that's just 1, right? So 1 times 2 is still 2, so we can actually say this is the same thing. So if we were to follow the same procedure for, like, if we had x to the n, then to take the derivative of this, we said it was nx to the n minus 1, right? To take the derivative of this, we're going to multiply the coefficient by the exponent. We get n, subtract 1, n minus 1. But if we were to follow the same step here, 0 times 2, well, that's 0. And then it's going to be x to the 0 minus 1. So that means this is going to be equal to 0 to the x to the negative 1. Well, 0 times anything, it's going to be 0. So it means that the derivative of a constant is 0. 0. So back to the example where we had d of dx of 3x plus 2. The derivative of 3x, well, that's basically 3x to the first. 3 times 1 is 3. Subtract 1. 3x to the 0. This will give us 3. The derivative of a constant is 0, so 3 plus 0 is equal to 3.